Well, guys, today we're going to discuss what a linked list is and how to create one in Python. So basically, what a linked list is it's it's a collection of nodes. So what are nodes? That's the first question, right? Imagine having a number 2 somewhere inside your memory. It can be 2, it can be 1, it can be 3, it can be 1,000, it can be 10,000, does not matter. The way it works in a normal list or an array is that you have indices. You have indices. So that becomes a collection of your data with indices. Now, if you want to reference to this number, you need to know the address, the index address, right? You need to know this. So as long as you can call this while referencing this whole list address, you can always get this element. And same goes for this one and this one. But what if I don't want to have these 3 different values inside one linear structure? What I want to do is, in a single memory space, what I want to do is I want to randomly access values that may be in different sequence or in different memory spots. So, for example, if, let's see how I can. For example, if I have a list 2, 3, 4, and I have another list 1, 2, 3. Now this list right here has been stored on my cloud AWS S3 bucket, and this list right here is stored on my local storage. Got it. What I want to do is whenever I arrive at this element, I want to reference the 2 here. I want to be able to climb to the 2 here. And let's say I don't want to get to the 2 here. So if I iterate, I want to get to this one and then keep iterating to the next one, to the next one. So I'm trying to sort of access element in 2 different locations, in 2 different data sets, for example, or data structures. So what do I need in order for me to be able to access 2 right here as long as I'm on this one? I need some sort of address, right? I need some sort of address. So do I create an address? Does the address exist by itself? What we can do here is we can use a data structure known as linked lists. It's obvious with the name. Linked list is lists that are linked together. So these 2 lists need to have some sort of a link through a reference, through a memory, through an address to link its elements as an object. Because this itself is a data structure. So unless we make objects out of these elements, we cannot reference. We can create instances and we can use object-oriented programming to reference or to refer to the 2 elements. It's the same concept as if I had 2 classes, class A, and I had a class B. Class A has a variable called v1. What I want to do is I want to use the v1 in the class B. So what I would need to do, I would need to create an object, an instance of the object of class A, which will be class A dot v1. And then I can use the elements of class B. For example, class B has v2. And then I can add these 2 to give me, for example, a v3. And this is how the object-oriented programming works. But I want to do this um, with lists. I have two lists, and I want to link their elements and want to be able to operate upon them as a linked list, as a independent data structure. So what do I need for that? I need to definitely create objects where I can reference, create instances of the objects, and then I can operate upon them through some means, through some operation. So in this case, what we're going to be using are the concept of addresses or reference or memory address, and or we can use something called pointer. A pointer itself can be a memory that references or points to the memory and helps you access it. But rather than getting to the details of what they are, I would like to go ahead and create a diagram of what a linked list can be demonstrated as. Okay, so what I'm going to do is I'm going to create a node. And I'm going to explain in a second what a node means. So I'm going to create another node and another node. So the idea is these nodes are basically variables. Where is my annotator? Right here. These nodes are basically variables that can carry a data in number or a character, string, whatever. But they have to be linked lists. So let's say if I were to assign a number 2 here, 1 here, and 0 here, I need a way to be able to point from 2 towards 1 and 1 towards 0 and 0 towards nothing to put an end to it. So in that case, it would be null. So imagine if these were just elements of 3 separate lists. Comma, and comma. These are 3 separate lists: list 1, list 2, and list 3. And what I'm essentially trying to do is I'm trying to find a way to link these elements linearly and create another list called a linked list. For that, something's clear to me that I need to create nodes. And imagine if these were just elements, these were nodes. Okay, so these are not nodes. Let me clear that up for you. These are not nodes. These are just elements, normal elements inside a list. So in order for me to reference, I would need to know the address of this element, address of this element, address of the where it is inside the memory, because this data structure, the list itself, has a bunch of addresses, a bunch of memory spaces that have addresses. So as long as I can point to the right address, I can always get to the right element, right? How to do that? Well, in linked list, what we can do is we can take a number, create a node out of it. And what a node essentially has a value. So this is a node. This is a node, and I can call it a node 1. This is a node, this whole circle including number. You need a number or a data, and then you need reference to the next node. Data and reference to the next node. Data and reference to the next, which does not exist. So if we had another node we wanted to add, we could have added it. But then the newer node would have to point towards null. So in this case, we have a linked list where it has the first node as head node, that's what we call it, and the last node pointing to null. But how does it look like programmatically? How are we going to do it operation-wise? Well, let's take a look at it. I'm going to go ahead and clear all the drawings and start from the beginning. This time I'm going to make it more specific with the kind of operations we can do and how to do operations in them. So first node, second node, third node. First node pointing towards the second, second pointing towards the third, and third pointing towards null, which is no value. So the first node, I assign it a value 1, 2, 3, and I call this a head node. So how do we know this is a head node? Well, a head node is a linked list that is already finalized. A finalized linked list that's there, because linked list, the way it's formed, is not that you can just type it just like a list, or you can just type brackets and put stuff in it. No. For the creation of linked list, it follows a process. It has to be created. It's a data structure that includes classes and has to follow a process. It uses functions to add elements to it in order for it to be called a linked list and to be seen as a linked list having objects. It has a basic structure, of course, just like an empty array. But then in order for you to be able to see it, you need to follow a process. And I'm going to explain in a second what it looks like, what it is, and how to create and generate the process. So we have a head node, and the head node is basically how to define if something's head node. What we can do is we can create a variable named head, and whichever node the head points to, it's the head node, is the starting node. And then that node has a reference towards the next node and the next node, and so on. Each node only points towards the node that comes after it. It does not point to the 3. So if you wanted to get to the 3, you would need to first get to the 2, and 2 would have the address to point to the 3. And if you want to get to the null or end of the linked list, you would need to get to the 3 in order for you to be able to reference to the null. Okay, that's simple enough, I guess. So how do we go about creating it? All right, here's the fun part. Let's say if we did not have a linked list at all, how would I go about creating it? What I would do is I would assign a value, and the value should be pointing to something, okay? A value and a pointer. Now I don't know where it's going to point to, right? So what I do is I create a head pointer, okay? And what I do is I assign the head the value of the node or the node, okay? What if this is the only node I have in the linked list? Which means if this is the only node in the linked list, it's supposed to be pointing towards null because there's no other node. But also this is the head node. So what I do is set head equal to 3. Plus 3 needs to be pointing towards null. So pointing is different, it's separate than assigning the value. So this is our linked list, which has only one node. What if I want to add another node? Well, in that case, what I'll need to do is I'll need to point head towards the next node or the new node. So imagine I create a new node, let's say 2, right? Okay. And 2 needs to be pointing towards 3. So I do is I point 2 to 3. And does that remain head? No, it does not remain head because now I have another node and the head is always at the beginning of the list. Therefore, and the end of the linked list is pointing towards null. So this becomes the end and this becomes the new head. Okay, so that means now the 3 is our tail, the last node, which is pointing towards null, and the newer node is 2. Similarly, if I want to add another node, 1. 1 needs to be pointing towards 2, and the head needs to be pointing towards 1. Now, our new head is 1, and 1 is pointing towards 2, and 2 is pointing towards 3. So now our head pointer, our head value is 1, and our tail value is 3. The last one is 3, and the middle one is 2. And you can have as many nodes as you want in between. You can have 1, 2, 3, 4, 5, 6, 7, 8, 9. But the last one needs to be pointing towards null. That seems simple enough. Now, there are many ways to add nodes to the linked list. But we always start with pointing towards null. So if you wanted it to be 3, 2, 1, and you wanted 1 to be pointing towards null, so you would have to start with 1 as the first node, not the head node, the first node in the linked list. And then as you would move forward, you would add 2 and 3. And then 1 would be pointing toward, would have been pointing towards null, head would be your 3. So it will look like this: 3, 2, 1, and pointing towards null. Now, in Python, it's pretty easy. It can get confusing, but it's pretty easy to create a linked list. I have an example here. I actually got this from ChatGPT, and that's where I actually learned it from, how to implement it. And it's a fun concept. So if you look here, the first thing ChatGPT did was created a class node, defined what a node is, what kind of properties it has. So it ended up creating a default function, a constructor, and then used self parameter data, and then went ahead, created linked list class, and in linked list class, it defined a head, and then went ahead and created a method that would help you add nodes and define new nodes, and pointed the head function to the new node and kept repeating it by calling the function and adding it. And if you run this, it's going to give you 3, 2, 1, and 1 pointing towards null. So if I were to reverse the order, so 3 would be pointing towards null, and 1 would be our head. So it will become 1, 2, and 3. So 1, 2, 3, 3 pointing to none. Okay. I'm going to go ahead and code it from beginning to the end. So step by step, at each step, I can explain to you what it is and how does it work. So let's go ahead and create a new file, a Python file. Let's go ahead and save it, because whenever you try to run it, it's going to ask you to name the file before it actually starts compiling it. So I'm going to name it linked list. Okay. And now I'm going to go ahead and create so first thing, what we need to do is we need to define what a node is. We need to define to the VS Code in Python, what do we mean by node? We can create a default function, initiator, and self data. So self.data, the data variable inside this function is equal to data, which means that whatever value you assign, it can be called by this constructor right here. Let's say if this value was 3. So if I were to point to 3 in this class, I would be able to do that. Okay. And self.next. A node has the ability, which means that the value of node, if called with the data, would be 3. And when it becomes 3, you can always point 3 towards something else, right? So that would be equal to none. Okay. So let me explain this a little bit. I feel like it will be difficult for some people to understand this. So let's say if my class is node and I assign a value 3, right? So this will be self.data, and I call this data. Okay. And which becomes part of this node, right? It's pointing towards this node. And when I say self.next, now since this became the definition of node, now the node or the new node, just make a node, will be able to use this, which means if the node is 3, if the value of node is 3, the node will be able to call the self.next or node.next. So if you call it a 3 self.next, is the same as pointing towards something. And if you say 3.next, 3.next is the same. And if 3 is the node, it can be node.next. And if the node is your self.data, so self.data.next. And that's how the logic follows, okay? All right, so let's go ahead and clear this up, clear all drawings, and let's continue writing the code. So class, and I'm going to create a linked list, okay? A class of linked list. And here, what I'm going to do is create another self data and self dot, okay, we don't need data here because we don't need a new variable data here. We already have it. So self dot head, we create a new variable named head, and the head is basically pointing towards a class. And right now the linked list is pointing to nothing because the head is pointing nothing. And the only thing that actually defines the linked list, helps you navigate it, is the head pointer. So right now it's pointing to none. So since it's pointing to none, now we can go ahead and create a new function that will help us add new nodes to the linked lists. So init, and now we're going to add self data. Made a mistake here. So append, or let's call it add node, right? Self data. Okay. And now we're going to go ahead and start adding new nodes to this. Okay. So first of all, as we know that the first node has to point towards null, no matter what value assign it. So let's say if the newer value, if the new node has a value, new node, if I define new node, okay, has a value 3, right? How do I do that? Well, right now I'm not going to worry about 3. I'm going to worry about the data because whatever I input in the data will be the value of the node, okay? So what I do is I do node, I call the node class, and inside the node class, I assign the value data. So whatever input I put here, it's going to use that, okay? So whatever value you put for the data here, it's going to reference, or it's going to store the value in the node class, right? So if, let's say, if you were to, in this function, if you were to call this function and you gave it value 3, this 3 would store here, and this will actually go reference this. And now since it's this 3 is the part of this node class, now it has an ability, as we discussed, to point to something, right? So 3 can point to a value that we want to assign it. So initially, what we need to point the value, of 3, or the data, is we want to point it to null, right? So right now the head is equal to null, head is equal to none. So what I'm going to do is I'm going to say that the new node, which is a 3 or whatever the value, dot next is equal to self dot head, right? So it's the value of the self dot head is none, right? As you can see here. So right now my new node dot next is pointing to, the pointing to is towards the none. But the next step we need to do is we need to actually call this new node a head, because that's a head node, right? It's pointing towards null, but it is a head node. So what we're going to do is we're going to say that the head is basically equal to new node. So the value of new node is head, but the head dot next was assigned to this. So That's what our value is. So we're having a slight issue. I think I might have missed out something. Okay, so self.head is so self.head. So the value of new node was pointing towards null, and now the self.head gets assigned the new value, which is the new node will point towards the null, but then the actual value 3, or whatever the value was, it will become the self.head. Now the head is pointing towards 3. And let me diagrammatically clear it up one more time so you don't have any confusions. So basically what we did here is we said, for example, that the value is 3. The value of data is equal to 3, okay? And this is our node. In this step right here, what we did, we say that our new node, its next value is the value of the self.head right here. And the self.head is equal to none, right? So now the value of the reference of this node is none. But now we need to change the value of the self.head, because now the self.head was first pointing towards this, but now it needs to point towards that, right? So this becomes our new head. So we say that the self.head needs to point to the value of the new node and not to the address. So there's a difference. The value of the new node, which is this, new node is 3. The reference of this node is towards none. So we need to change the head from the value of head from none to 3. So now our linked list looks like that, with head being this. And as we keep repeating the process, we're going to keep changing our head to the newer values, right? And we'll keep going on. Okay, so I'm going to go ahead and remove this. And I'm going to go ahead and I'm just going to copy the display function. I don't want to get into details of how display function works. It's pretty simple. You guys can look at it later after the video for your reference. So I'm going to paste it here. And here, so the display function, what it does is it creates a new pointer current, points it to the head, and then keeps iterating until it arrives none. So basically, if you had this linked list 3, 2, 1 pointing to null, right, or none, pointing towards that. So your current pointer would be here, and it will keep looping, keep going, finding the next node until it hits null, and it will finally print null. And every time it arrives at a node, after that node, it adds a string such as this, which is this pointer right here, right? So that's how it works. So while current is true, while there is a current node, current.data, print it, and then do a current.next and keep going on. It's pretty simple. You guys can take a look at it. And I'm also going to, okay, so now what I need to do is I need to create an instance of this class, the linked list, to use the function add node. Okay, so what I'm going to do is let's create a linked list is equal to, so I'm going to create a instance, so it's slightly different spelling, and then I'm going to use the linked list class to point to, and of course add a tuple. And now I'm going to do is I'm going to call instance, right? I'm going to call the method, create an object of that method. So add node, and now I can start adding, since this takes values in the form of data variable, I can start adding 3, and then I can replicate this. I'm going to change this to 2 and 1. It's going to add new nodes. And finally, I need to call, once the linked list has been created, the next thing I need to do is I need to call the display function to display the linked list. So in this case, what I'm going to do is linked list dot display, calling the display function, and it's going to display the linked list. Okay, so I'm going to go ahead and close this out and discard everything, and now I'm going to run this. and let's see if it gives us the linked list. It did 1, 2, 3. So if you wanted 3 to point, if you wanted 1 to point to null, so 1, 2, and 3, and then here you go. You have a newer look of how another way of making it look like the way it looks like. Whatever. Okay. So this is our linked list, basic linked list, and how to add a node in a linked list. This is just lecture 1, and we're going to discuss circular linked list, W linked list, and how to perform other operations, how to insert a new node in a linked list, how to delete. And once we are familiar with how to do those, we'll jump to the lead code questions for linked list and get some practice there. Thank you very much for watching. If you guys have any questions, ask in the comment section. You can also ask in the WhatsApp group. I'm available, and yeah, have fun.